whatever they want to eat and found something to drink. We'll get this thing going. This is the second time now that we've done a Zoom webinar at the same time with an in-person event. So we're still getting our feet, sort of stable doing around this, but we think we've got it set. We've got 30-some people online right now. So I'll get us going. Evening, everyone. Welcome to those of you who are here in person and to everyone joining us on Zoom. I am Michael Bernard, the president of the MIT Club at Puget Sound. We're glad you joined us this evening for this event, including those of you from our peer IB Plus schools and whoever else managed to find out about it and show up. That's all good. Hope everyone's enjoying the pizza here and whatever you're eating at home. Quick note on logistics. We are video streaming and recording tonight's program. Thanks go to Jen Camacho, who works for the MIT Alumni Association back east, and so she's online running the webinar basically. She's an associate director of alumni outreach there. And then to Brian Moran, he's our current VP of programming, also AV wizard right now. So we expect Dr. Gilbertson's talk to run about 45 minutes plus then Q&A for say 10 or 15 minutes. Hopefully we'll be wrapping up around 7:45 or so. I want to say something about the club. The MIT Club of Puget Sound is an all-volunteer organization for MIT alums, students, and family in the greater Seattle area. Throughout the year, we have a variety of events, such as, well, just a couple days ago, we viewed beavers over at Magnuson Park, which was way cool. There's this Beavers Northwest organization that takes care of beavers, does all sorts of stuff. And so we actually got to see beavers. It was like really neat. Let's see, we've had tours of Blue Origin recently and an Amazon distribution center. We're doing some hikes this time of year, and our annual summer picnic is coming up later in July. Please consider becoming a paid member of the club, as well as helping volunteer with event planning, communications, treasurer, you name it. We can find a role for you if you're interested in helping. Besides myself and Brian, our VP of membership, Julia Shea, with the big MIT sweater, is also here as well. Feel free to chat with any of us at some point if you're interested in helping with the club. Now, to get us started, thank you for joining us for tonight's speaker event. Effort to determine, measure, and climb the highest mountain in every country on Earth. Our speaker, Dr. Eric Gilbertson, who's got 3 degrees, his bachelor's, master's, and PhD, all from MIT. He's currently an associate teaching professor in the Department of Mechanical Engineering here at Seattle U, where he teaches statics, dynamics, surveying courses, and an advanced control class involving robotics. Dr. Gilbertson will discuss his efforts or it's in the title. Contrary to common belief, many countries in the world have not previously been surveyed accurately enough to know which mountain is the country's highest peak. So he has so far discovered new country high points in 8 countries. Results have been published in scientific journals and covered in major news outlets. Please join me in welcoming Professor Gilbertson.
Thanks. Yeah, I'm working on a project to climb the highest mountain in every country on Earth, and along the way I need to figure out what's the right mountain to climb. So next slide. So this map is kind of an overview of my project. This color codes the countries by what I've climbed, what I still need to climb. So blue on this map means I've climbed the country high point. Light blue is I climbed the highest legal point. So there's a few countries like Israel where there's a military base and I just got outside the fence and I didn't go the extra 5 feet inside the fence. So highest legal point. And then red is I just visited the country, haven't climbed the high point. White, I haven't even visited it. And then the orange one is I've climbed only the mainland high point. So for instance, Denmark owns Greenland. So the highest point in Denmark is actually in Greenland. So I've only done the mainland one there. So I define countries as UN members and observers plus Antarctica. So 193 members plus 2 observers, Holy See and Palestine plus Antarctica. So 196 total. So I'm about 3/4 of the way done so far, 153. So still a lot of hard ones to go. Next. So I want to go over what are the challenges involved in climbing country high points, give some examples for each of the challenges. And then I'll go for the biggest challenge, which I'll go into more detail, is finding what's even the right mountain to climb. So the first challenge is jungle bushwhacks. So you get these a lot in the Caribbean and also in Southeast Asia and the Pacific. It's like St. Kitts and Nevis, Grenada, they have razor grass. There's thorns on everything in the jungle. A lot of times there's no trails. So you learn if you fall in the jungle, you don't grab onto the nearest thing you can hold. You tuck and roll, because there'll be thorns like that one in Brunei. And the progress can be really slow. Like in Brunei, the high point was like 1.5 miles to get there, and it took like 9 hours. So bushwhacking can make things really slow. Next. So the next type of peaks is in the desert. So it gets really hot in the desert. So for instance, in Kuwait, August is probably not the best time to go there. It was like 120 degrees. And then at night, it only got down to 90. So it's really hard sleeping in the car. Jordan is pretty neat. If you've seen the movie The Martian, that's where that was filmed, in Wadi Rum, and the high point's out there. So deserts can be fun. A lot of Mideast country high points are in the desert. Next. A lot of countries can be politically spicy. So for instance, Cuba, when I went there, it was closed to tourism for Americans. So how do you get there? It took like 5 years to figure that out. We got this special visa, like people-to-people exchange, a lot of red tape. There's ones like Israel where there's a military base on top. I'm still working on permission, how to like officially get that one. Central African Republic is a good example. We needed permission we needed escort by a policeman and a military guy to go to the top. That was the only way. And so the military guy had to pass his AK-47 underneath the chalk stone on this scramble to get to the top. So we figured that one out. Next. Sometimes you need stealth missions. If I can't get permission, sometimes I'll sneak in. So for instance, in Nigeria, I came in, the high point's on the border with Cameroon. So I came in from the Cameroon side, and there's a lot of checkpoints, but they're not super active at night, like 3 a.m. And if you come through with a motorcycle, you can kind of get around the checkpoint. So on the way in, we motorcycled around the checkpoint before they noticed we were there. So then on the way out, it was a little bit more difficult, but we also motorcycled around. You can kind of find trails that avoid roads. So some of these are stealth missions. Turkmenistan, I went in from the Uzbekistan side. It's on the border. And went on a full moon night, didn't use headlamps, and it was Uzbekistan Independence Day the next morning. So we figured the guards wouldn't be out. So I did get caught at the end, but they couldn't take away the fact that I got the mountain. So a lot of these are stealth. Next one. A lot of times there's bad weather on these mountains. So for instance, on Everest, I had to spend like 2 nights back to back at 8,000 meters waiting for the wind to die down. And that kind of killed my acclimation. So I got the south summit, but then I had to bail. So that didn't work out too well. Georgia, we got up like 18 pitches of ice up to like 15,000 feet. And then summit push, it snowed like a foot. So we had to bail. We only had 1 summit day. So bad weather can affect country high points a lot. Next. A lot of times you need bribes. There's a lot of corruption in developing countries. So for instance, in Central America, I rented a car and drove around between Guatemala and Honduras. Every land border crossing with a car in developing countries is very challenging. You have all kinds of helper people, and you have to pay them each a bribe. So to get around that, the next time I went down, I was in Haiti and Dominican Republic. So I came in from the Dominican Republic side to do the Haiti high point. I said, I'm not going to rent a car. Cars are complicated. I'm going to bring a bike. So brought the bike to the border, foldable bike, got through. They didn't really know how to get bribes, but they still wanted a piece of the pie. So there were 10 guys around. So what I did was take a $20 bill, threw it on the ground, and they're all fighting over it. Then I biked away. So that solved that problem. Zimbabwe, I actually ran out of money from bribes, and then I came up to this police officer who wanted a bribe. So I gave him my lunch, and he said, that's okay, since I didn't have any money. Next. So a lot of the country high points are technical climbs. So Pakistan K2 is pretty technical. There's fixed lines on that one. Uzbekistan, there's no fixed lines. That's like kind of like Grand Teton. I'll go into more detail on that one. That requires surveying and climbing. Kenya was like a 20-pitch rock climb. Georgia, like an 18-pitch ice climb, but we bailed, so we didn't make that one. So next. Another category of difficulty is altitude. So 7,000 meter, 8,000 meter peaks will take many weeks just to acclimate. So I usually try not to use oxygen, so it takes a lot longer and it's a lot cheaper. So for Pakistan, that was like a 6-week expedition to get K2. Afghanistan is probably 3 weeks. That's a 7,500 meter peak. Kyrgyzstan was like a 6-week expedition. So these take a lot of time if you want to acclimate properly. Next. So not all country high points are hard. Some are easy. There's probably a couple dozen there's maybe a dozen or so you can actually drive up almost to the top. So for instance, Malta, you can basically drive up. Qatar, I could actually stick my foot out the car and touch the high point. That's pretty rare. Luxembourg, you actually bike to the summit. So a lot of these are in Europe. They're pretty easy, almost drive ups. There aren't too many of these though. So next. And then the final category I would say is good old-fashioned hikes. This would be like a 10-mile hike, just a day trip, standard trail all the way to the summit. Like Mount Fuji in Japan, pretty standard hike. Like Czech Republic is day hike, Jamaica is a day hike. There's a lot of these in Europe that are day hikes. So you have a lot of really challenging countries and some that are not so challenging. But of all these challenges, I would say the most difficult is figuring out what's the right mountain to climb. So if you do a 6-week expedition and climb the wrong mountain, then it doesn't help at all. So I want to go into more detail in this presentation in how do I figure out what's the right mountain to climb, what's the highest mountain in the country I'm going for. Okay, next slide. So before I started on this project, I kind of assumed the world had already been mapped very carefully. Like satellites have already figured the elevation of every mountain in the world, surveyors have been everywhere, everything's very well known. But then in 2018 is when I first figured out actually not every country's highest point is even known. So what you might read online, when I start digging in deeper and deeper, you can't find the original source. So it's hard to know if you trust that mountain's the highest in the country. So looking back now, as of 2018, there were like 24 countries that it was still unknown what was the highest point. So that might be a little surprising until you dig into why. So like in West Africa, there's just not been a lot of ground surveys. There's not a whole lot of interest in that. Europe and North America, there have been a lot of accurate surveys. But even though satellite surveys exist for the whole world, for like all landmass on Earth, it's still not accurate enough in many cases to know what's the highest mountain. So there's not anyone else that's going to go figure out what's the highest mountain in every country. I kind of had to figure it out on my own. So that means I have to kind of turn into a land surveyor, learn how to do land surveying. So next slide. So why am I qualified to be a land surveyor? So I'm a mechanical engineer, but I went through grad school at MIT, and what that teaches you in grad school is you'll often be given a new sensor and you just got to figure out how to use it. And then take a bunch of measurements with it, interpret the results, and write a paper. So that's a lot like surveying. Surveying involves just learning a bunch of new equipment and then taking measurements. But then the equipment's kind of expensive. So I teach at Seattle University, and we have a civil engineering department here, and we have surveying equipment at the university. So this is like equipment you'll see construction workers on the side of the road. They have like theodolites that measure angles. They have these fancy GPSs that sit there and get your position really well. So I basically use all that equipment, and I try to find elevations really accurately. So let me go over what is the equipment I use. Next. So I got into surveying locally. So I don't want to travel all the way to some other country on the other side of the world and just then try to figure out how to use the equipment. I gotta figure it out locally first. And when you bring equipment up in the mountains, nothing ever works exactly as you expect. So I want to get a lot of data points before I go to another country. So I started a project in Washington to figure out what are the 100 highest mountains in Washington. So it turns out if you just look at the USGS quads, they're not quite accurate enough to know exactly what are the 100 highest mountains. The quads have errors, and they're only rounded like to the nearest plus or minus 40 feet with the contours. So I started hauling a theodolite up mountains out here. So that's the thing in this picture. It measures angles really accurately, but it's really heavy, so people don't usually bring it up in the mountains. So that's one tool I learned how to use. And then, next slide. So there's a bunch of other tools I use as a surveyor. So on the top is an Abney level. So I first used that in 2017. Katie gave me the idea. So there's this peak called Sherpa Peak, has a really hard summit and an easier summit. And I wanted to know, do I have to do the harder summit? And so if I can measure an angle in between them, if I'm on the easy summit and I'm looking down to the hard summit, it's definitely shorter. If I'm looking up, then I got to climb it. So that was my first surveying measurement in the mountains. So that can measure angles. If you have two summits close together, you can figure out a relative angle. It's like 10 arc minutes. Then on the next one is a differential GPS. So that's kind of like this one. This is what Seattle University has. So it has the antenna, you put it on a tripod, you measure the antenna's height, and you subtract off this antenna rod, and you have this touch the top of the mountain. And this logs a bunch of data. And so it's like a really fancy version of what's in your phone. So your phone might get within 10 meters of vertical accuracy, and this device, if you log data for an hour or two, you can get a couple centimeters of vertical accuracy. It does things like correct for atmospheric distortions. You can compare data to other base stations nearby. It can deal with multipath and collect a lot of data. You can post-process it. So that's really good, but you have to be exactly on the summit to get that number. Then on the bottom right here, there's a photographic analysis tool one of my friends wrote. So if you take a picture looking at a peak of interest, and you can identify peaks in the background of known location and elevation, you can enter those in the pixel coordinates, and you can get a relative height between your camera and the other peak. And so this is good if I've never been to a peak, but my friend's been there and took pictures. Then I can get kind of an idea which peak what's the relative height. Then in the bottom, there's LiDAR. So that's where a plane flies over, bounces a signal off the ground. If the plane knows its height, it measures the time to the ground. You can measure the mountain height. So that's available in North America, Europe, and some Pacific islands like Tuvalu. And then I bring a theodolite up to some mountains. I haven't brought that internationally, but in the US, that can get 20 arc seconds resolution. So it's a lot more precise, but it's a lot heavier. This is one other tool that I use for countries. So next slide. So next tool is satellite-based measurements. So these are called satellite-based digital elevation models. So how these work is in the year 2000, NASA flew a mission. Shuttle went all over most of the Earth, and it sent signals down and measured the time of return. The shuttle knows its height. Measure the time of return, you can get the ground height. And each of those measurements was within plus or minus 16 meters according to NASA. But they're not taken continuously. They're only taking at 30-meter spacing. So it gives you a good idea of elevations of points around the Earth, but there's a lot of gaps. And so how are the gaps filled in? People approximate what the Earth is between the gaps. So this picture shows, if it's smooth terrain, the gaps will be pretty good. The digital elevation model will be pretty good. But if there's a sharp peak in the gap, you'll probably miss it. So it tends to underestimate sharp peaks. No one knows exactly how much because they haven't really been compared with ground measurements. So I'm working on a paper on that now, but we don't really know. So if you open up Google Maps or Google Earth and you hover around, there's always an elevation under your mouse. That's because it's a digital elevation model in most cases. So those have high error, but they have global coverage. So that's a really important tool for identifying country high points. Next. So each of these measurements has a certain uncertainty. So satellite-based digital elevation model, each measured point is supposedly plus or minus 16 meters. No one really knows between measured points, though. Every digital elevation model is a little different. So best case 16 meters, but probably a little bit worse. Abney level, I have 10 arc minute resolution. So if there's two peaks close together, I could get within a foot or so. If they're far away, I could get within a couple meters. Theodolite, I have 20 arc second resolution. So if peaks are close enough together, I could get within a foot or so vertical, relative. LiDAR, I've done some research, is accuracy plus or minus half a meter vertical on mountain summits. And then the differential GPS is a couple centimeters vertical. So that's the best. Next. So my methodology for finding new country high points. First, I know now, don't just trust what you read online. for the highest mountain in a certain country. You need to figure out how did they determine that. And if there's no record of how they determined it, then it should be maybe untrustworthy. So what I would first do for like Gambia, no one surveyed Gambia very closely. You'll read online, Red Rocks is the tallest point in Gambia, but there's no source of why that's the highest point. So what I do for Gambia, or any country in general, first look at all the digital elevation models I can find and identify the highest candidates that are within that 16 meters of the highest point. So for instance, Gambia, I picked the top 4 contenders approximately. Gambia is all pretty flat, so the digital elevation model should be pretty good. I got 16 meters, it might actually be tighter than that. So I pick all the candidates from satellite measurements. Then I look and see if there are any ground surveys that have been done. So the Soviets and the British and the US military did a lot of ground surveys all over the world. And those are actually available online for like a couple dollars, like mapstore.com. If you can't find it online, like for Gambia, I just bought a map that was mailed to me. And so unfortunately, those ground surveys rarely publish their uncertainty. So you don't really know, but it's other data points if it matches up with digital elevation models. And so then once I narrow down to a set of candidate high points, then I'll go and bring the fancy GPS up each one of those. And if it's like a double summit, maybe I can cite one from the other with an ABNY level. And then hopefully that is as conclusive as I can get for what's the high point in the country. So I want to go in detail for 4 or 5 country high points where I figured out a new high point for the country. So the first one is Saudi Arabia. This was in 2018. And so back then it was actually pretty hard to travel to Saudi Arabia. They didn't issue tourist visas back then. You had to either go to Hajj or, I don't know, there was no known way for a tourist to go to Saudi Arabia. But I had a friend from the MIT Outing Club who was from Saudi Arabia, and he was the president of the Climbing Federation. And so he invited me and my brother to go there and climb the highest mountain. And this kind of got me and my brother into researching whether we were climbing the right mountain. It's so hard to get to Saudi Arabia back then, we didn't want to climb the wrong mountain and have to come back again. So started digging. Everywhere online, all sources online say Jabal Sauda is the tallest mountain in Saudi Arabia. But they don't really cite why it's the tallest. So I started looking at digital elevation models. Next slide. So if you look at Google Terrain Digital Elevation Model, left is Jabal Sauda and right is Jabal Farwa. So you'll notice they're within the same, if you look really close, they're within the same contours. They're both between 2980 to 3000, 2980 to 3000. If you hover over on Google Earth, they're like within the error bounds. All digital elevation models have them within the error bounds of each other. So it's inconclusive if they're within 16 meters on the DEM. So next I looked at what ground surveys have been done. Next slide. So the Soviets did a ground survey in 1978. Sauda on the left was surveyed at 3032. Jabal Farwa is 3091. So it looks like Farwa was taller. So that's kind of interesting. There's no error bounds on those measurements though. They were probably done with a theodolite, but you don't know how far away they sighted. So unknown what the errors are. So next slide. So next I look at US military surveys. So in the US military survey, Jabal Sauda at 3015 and Jabal Farwa at 3020. So Farwa was also taller. So these are the only ground surveys I could find. So they both say Farwa was taller. Satellite measurements say they're tied. All the online sources say it's Sauda. But there's no source that says Sauda was measured taller. So I figured what we need to do is survey both with the fancy GPS. So that was the plan. But I didn't know how you get one of these fancy GPS units. I wasn't at Seattle University yet. So it turns out there's companies that rent them. It's about $500 for a week. And you're on your own for processing the data. You don't just get well, you'll get a number, but you have to process that number. So I have a friend that does GIS, and he said he'll process the data. So I rented this unit and brought it to both summits. Next. So this is what the unit looks like. It's on the left on Sauda, it's like this big boulder, and on the right it's on Farwa, also these boulders. So I didn't Usually you should mount it on a tripod. I didn't really know any better back then. It should still be pretty good data. Tripod gets it off the ground, you get more satellite view. It helps with these multipath issues. But we took enough data that it was conclusive enough to say which one was taller. So next slide, I'll show the results. So on the left here, I'm plotting elevation versus the peak. Farah's on the left, Farah's first, and then Sauda. And the different colors represent different processing with different base stations. And this box and whisker plot, the box edges are 1 sigma, the whiskers are 2 sigma. So the green bar is for this base station called Kuwait. So what this means is in Kuwait, there was a fancy GPS that's been sitting on the ground for like 30 years. It knows this location very accurately. So if atmospheric distortion is making it read a little bit like a meter too high, you'll know. So what I do is I say, if it's reading a meter too high in Kuwait, then it's approximately reading a meter too high where I am, if that's a close enough base station. So I can do that for different base stations. There's another one in Kuwait, there's another one in Addis Ababa. And so this can correct for atmospheric distortions. So this gets an elevation for Farah and an elevation for Sauda. So with 3 different base stations. So you'll notice the Sauda are all a little bit shorter than the Farah. So if we pick the green. Kuwait was the closest base station, which would theoretically be the best for atmospheric distortion. Then on the right is a histogram, normalized histograms, like number of measurements versus the peak elevation. So Sauda is in blue and Farah is in red. And if you took like 1,000 data points, most of them would be in the middle there, around like 3,002 for Farah. Most of them would be in the middle, around 2999 for Sauda. So you notice the Farah numbers are higher than the Sauda numbers. So we can pick out a sigma and we pick out a mean from the data. And you can do some probability analysis and figure out what's the probability a random Farah measurement is taller than a random Sauda measurement. So with those values, it's 99.9% that Farah is taller than Sauda. And so usually 95% is the cutoff. If it's more than 95% confident, then we'll say, okay, we trust enough that Farah is taller. So from this data, we concluded Farah is the tallest point in Saudi Arabia. Jabal Sauda is not. So now an interesting thing that happened after this measurement, my friend went in last year and took another measurement of both peaks. So my measurement had Farah 3 meters taller. He measured Farah was only 1 meter taller. But there had just been a bulldozer up there. So they're building an apartment complex on Farah now. So they bulldozed the top off until they got to rock slab. So it looks like they're not going to get any deeper than the rock slab. So I think Farah will stay a meter taller than Sauda unless they dynamite or something. So it's a little bit unknown. What do you do if the high point changes like that? So I guess I've already done both. So that's okay. So the next mountain I want to go over is a little more difficult than the Saudi Arabia high point. So sometimes the highest mountain in the country is known, but the location on the mountain that's the tallest is not known. So the highest mountain in Kyrgyzstan, everyone knows is Puget. This is one of the hardest, I'd say it's probably the hardest country high point in the world. It takes like a 6-week expedition, super technical, super dangerous, the weather's really bad. Got like frostbite on all my hands when I climbed it. Everyone knows Puget is the tallest. It's been surveyed in 1940 by the Soviets. But there's 3 bumps on the ridge. And it's a 700 meter long ridge. And it's not trivial to get between them. It's mega corniced. If you have to spend an extra 2 hours up there, you might not come down. You want to tag the right summit and get down. So I wanted to climb the right summit. So I did a little research in advance. So next slide. So Pobeda is located on the eastern corner of Kyrgyzstan. It's on the China-Kazakhstan border. The weather gets really bad because it's on the Taklamakan Desert. And I guess the wind comes in that way from China. It's always really cold. And it's far enough north that supposedly the oxygen content is low enough up there that it feels like an 8,000 meter peak if it were in the Himalayas. It's really difficult. Next slide. So it was surveyed in 1940 by the Soviets. So you use standard theodolite survey. This should be really accurate because you can get a theodolite to base camp. And if you can sight it, the summit, with the 20 arcsecond theodolite, you should be able to get it within a meter. So they surveyed the east summit was the tallest, 7439.3. West summit definitely shorter, central summit definitely shorter. The first ascent team in 1955, they climbed the east summit. So by all accounts, the east summit is the highest. I decided to bring an Abney level with me just in case, but I was going to target the east summit. And the most direct route to the east summit is one of the hardest routes on the mountain. The normal route goes over the west summit first, but I think it's safest if you can go direct to the summit, and then if you have to bail, you go directly back down versus staying up on the ridge. Next slide. So this was the route I took. It's called the Balakov. Kind of follows this big corniced ridge just direct up. It directly hits the central summit, and then we just went over to the east and then came back down. So this took about 5 weeks to acclimate because it's about 7,400 meters, and then 4 days up and then 2 days down. It's probably the hardest climb I've ever done. Definitely wanted to get the right mountain there, get the right summit. So the Abney level, I was too cold to bring it out. I wanted to get on the east and like measure to the west, but I think the bubble probably froze anyway. It's just water in there. And I ended up getting frostbite on all my fingers, so it's probably good I didn't make it worse by taking out the Abney level. So we did the east summit, got back down, and we submitted, there's this like snow leopards committee. If you climb all the 7,000 meter peaks in the former Soviet Union, then they like certify it. So I told them I did the east summit, and they said, that's nice, but you're supposed to do the west. So doesn't count. Then I said, well, the first ascent team did the east. The only survey of the area said the east highest. Why do I have to climb the west? And they were like, well, you just do. That's the rule. So I said, okay, we're going to do some scientific rigor here. So what I did is I compiled all the measurements that existed on Pobeda. So there was the 1940 Soviet measurement. There's a bunch of satellite measurements, and I have the photographic measurements I can take. So next. So there's like 10 different digital elevation models on the top row there. Every like Google Earth, terrain, flood map has their own, Gaia has their own. So I figured out what were the relative heights of east, west, and central on the ridge from those. There's also another non-public satellite measurement that was taken by Airbus Defense in 2017. So that's more accurate than SRTM, the NASA one. It's like 25 meter spacing and plus or minus 10 meters instead of plus or minus 16. But it's expensive. It was like $1,200 for just one data set. So this was important, so I did that, and I analyzed it. And then there's the GeoPex photo analysis. So I took a picture. So one of these pictures is on the west looking to the east, and one's the east looking to the west. And you can see the little bump in the middle is central. And I can identify some peaks in the background that were surveyed on the Soviet map. And I could use GeoPex to figure out what's the relative height between the camera and the other peak. So I compiled all this data. It's like 11 data points. They all have a lot of error is the problem, except maybe the Soviet survey. Okay, next. So I tried to graph them. So this is a graph of height relative to central versus the peak. So central is always at 0. So each color represents a different way of measuring. So like the pinkish purple on the top of east, so that's like Soviet survey. Soviet survey measured east taller than central, west shorter than central. And then like the light blue is my photo analysis. It measured west taller than central, east taller than central. So east-west were tied within the error bounds. Ideally, I would find all the dots on east were higher than all the other dots, or all the dots on west were higher than all the other dots. But that wasn't the case. This plot is actually kind of inconclusive. Some measurements have east taller, some have west taller, some have them tied. It's just all over the place. So my conclusion, though, based on what I observed up there, snow accumulation is really heavy up there. You could have 50-foot tall cornices one year. In 1940 or 1950, the pictures I saw, east was rock. When I went up there, it was snow. So I think snow accumulation is really significant, and the peaks are all about the same height. So within maybe 10 meters, but snow might accumulate 10 meters. So my conclusion is no peak is always highest. It depends on the year. So 1940, east was highest. In 2000, east-west were tied. 2017, central east were tied. And then 2021, it was like east-west tied. So this should hopefully not annoy any mountaineers that did only west or only east or only central. So this was a good conclusion, like politically. And it also matched what the early ascensionists did. So I found this 1960 interview with the first 3 guys who ascended Pobeda. And in the interview in Russian, I had my friend translate it, they said Pobeda is like a rooftop, where any point, if you ascend any point on the rooftop, you count that as the summit because they're all basically the same. So this analysis is kind of consistent with that. So I presented this to the Snow Leopards Committee, and they said, yes, we agree with your findings, but you still have to climb the west summit. So I didn't want to stop there. So there's actually a Supreme Court, basically, of mountaineers in former Soviet countries that supersedes, that like is more important than the Snow Leopard Committee. So I have a friend of a friend who's on that like Supreme Court, and I sent him my paper, and then the next day, so he then talked to the Snow Leopards Committee. The next day, they said, after careful review of your report, we have given you credit for the mountain. So if anyone's going climbing Pobeda, just climb all 3, and then you won't have to go through all this. So I want to move on to the next mountain. Sometimes the highest mountain in a country might be unknown, unclimbed, unsurveyed. So that was the case in Uzbekistan. So this is the mountain Alpomush. Kind of looks like Grand Teton, but it's like 20 miles into the wilderness there. And the interesting part about this mountain, like I said, it actually had never been climbed, didn't have an official, still doesn't have an official name. The surveyors missed it in the 1981 Soviet survey, and there was no beta on it, no pictures. So next. So this is a map of Uzbekistan. Yeah, what people used to think was the highest mountain in Uzbekistan is kind of unnamed now, Peak 4643. When Uzbekistan was part of the Soviet Union, it was called Peak of the 22nd Communist Party Congress. It's like a really weird name. Then Uzbekistan became independent and said, we don't like that name, but they didn't give it another name. So it was just Peak 4643. And so this was climbed 4 times. It had only been climbed 4 times before I got there. Survey team, then 3 of my friends climbed it. But when I was looking into going in there, I didn't want to climb the wrong mountain. So I started looking at all the mountains in eastern Uzbekistan. It turned out there was another one that was like tied for the same height. So I'm calling that one Alpomush. It's officially unnamed. Alpomush is like a mythological like character in Uzbek history, and some Uzbek person gave it that name before me. So I'm just using that name. So next slide. So I first looked at digital elevation models to make sure Peak 4643 was the highest in Uzbekistan. So Gaia has its own. And if you look down on the bottom, there's this peak that Gaia has listed a little bit taller than Peak 4643. So that's kind of interesting. Why are these people climbing this Peak 4643? So everyone I know who climbed that one was doing that because of the old Soviet maps. So then I looked into the old Soviet maps. So next slide. So it's the same area on the Soviet map from 1981. Peak 4643 was surveyed at the top. It has a little dot and the number on the top, which means a surveyor pointed a theodolite at it. Down at the bottom, where Alpomush is just blank. There's no local maximum, no survey point, no nothing. So surveyors actually missed it. But in 1981, it wasn't that significant because it was part of the Soviet Union. It wasn't part of Uzbekistan. So across the valley, it's on the Tajikistan border. Across the valley in Tajikistan, there's taller peaks. There's 5,000 meter peaks. So this one, Alpomush, is nothing significant compared to all the ones in the area. But once Uzbekistan became independent, then it becomes significant. But it wasn't surveyed back then. So no one really knew. The previous 4 ascents of Peak 4643, they didn't know about this blank spot on the map. Only because of digital elevation models was I able to pick this up. So, but the digital elevation models had them tied. So it wasn't really certain. So next slide. So just a handful of models. Google Earth has them exact same. If you hover your mouse over each one, they're the exact same number. And that number could be off by a lot. Other models have Alpomush a little bit taller. The 1981 survey doesn't even have Alpomush. So I would say, based on that, it's unknown. So what I wanted to do is go and survey both and to figure out which one's the tallest. Luckily, they're only about 6 kilometers apart, so they're close enough I could survey both. So next. So my survey plan, not what I've learned in the mountains, no survey goes exactly as planned. You need to have a backup plan, A, B, C, D, E, for maybe one of them will work out. So my primary plan, which didn't end up working, bring a fancy GPS to each summit, measure absolute height. Second plan, take Abney levels and measure relative heights between them. And then the third plan, there's a surveyed tarn, little pond, on the Soviet map. I could survey the summit of Alpomish from there and hopefully get an absolute measurement. So next. These peaks are pretty far in. The nearest town is in Tajikistan. The Uzbekistan side is landmined, I've been told, so you can't come in from there. So it's a 20-mile hike in from the nearest town in Tajikistan. The first 10 miles are trail for like shepherds, but the next 10 miles is kind of unknown. We didn't have any beta. No picture, nothing for Alpomish. Satellite image kind of made it look rocky and glaciated, so I brought a bunch of rock gear just in case. So that was actually a pretty good decision. So it took 2 days to hike in. Next. So the first view of Alpomish, we got this view looking from a pass. And I was really hoping that sharp pointy one was not our mountain. So I was hoping for a nice, easy third-class scramble. But that was the mountain. So when you get closer, it looks harder. Next. So this is what it looks like from base camp, from the tarn. That little tarn is 4,000 meters. So I took my first measurement up from there, and I got that the height was like 4,660 to 4,670. So that measurement showed me it was probably taller than 4,643. But now we had to climb it. So luckily we brought a lot of rock gear. So next. This is what the close-up view looks like. And there's no obvious way up. It's just a bunch of cliffs. So we just kind of went up to the base and tried to figure it out. We got it scrambled as high as we could up this gully, and then we had to rock climb from there. So it ended up being like 7 pitches, 5/8. And the rock's actually really good there. It's granite, good cracks. So there have been like 3 or 4 groups that have gone back in after reading about it. Like, I would go back in. I actually did go back in. I'll mention that. So next slide. So it's not trivial. Andreas's expression here probably tells you it was a little bit scary. He was climbing in mountaineering boots, which wasn't very smart. So I was leading in rock shoes. So we got up about 7 pitches. Next. So the summit looks like this, which is not a great location to mount a tripod. Like, this tripod here doesn't really balance on a knife edge very easily, but this was all I had. So my first plan of balancing on the summit was looking pretty difficult. So next. So I found this little nook in a boulder just below the summit. That's like the best I could do to mount it. And I stuck it there for 30 minutes and it never acquired satellites. I think there's just too much stuff blocking it. And also I hadn't turned it on since I was in Seattle. This is basically the opposite side of the world. So I think you need to like let it run for a little while first if it goes to the other side of the world. I didn't know that back then. So I got no data. And I wanted to stay longer, but a snowstorm was coming in. So we just had to get out of there. But I had the Abney level. So, and I could see peak 4643. So I took angular measurements down there. I actually brought 2 Abney levels just in case one was miscalibrated. And one's a 5x magnification. So it can actually see those 6 kilometers. So next. So this is what peak 4643 looked like in the distance. But with 5x magnification, I measured it was a 10 to 20 arc minute declination down with both Abney levels. So it already looks like it's lower. I mean, even with Earth curvature correction, that's not going to affect that it's still a little bit lower. But just in case something was miscalibrated, I want to go back to 463 and look back at Alpomish. And then if I'm measuring up to Alpomish, then it's a trustworthy result. So next. So turned out to be long, like 18-hour day, bunch of rappels, had to build all our own anchors. There's no evidence of anyone else up there, definitely unclimbed. So we got back to camp, next day hiked over to the next peak, and then the next day climbed it. And that one was also a little bit technical. Next. So this is the route up the peak 4643. So I had 2 friends that had done it, and they kind of told me the route. There's only a couple pitches of 5.7, so it's definitely easier. And so got to the top, and I brought the Abney level. I just didn't trust the fancy GPS at that point, so I just saved the weight. I should have brought it just in case, but I didn't. So I just had the Abney level. Next. So the top of that one is also pretty steep, but you see there's a cairn up there. So that was built in 1961, I think, by the Soviets. So definitely not a first ascent on that one. I think we were like the 5th ascent. Next. So you can see Alpomish in the distance. Luckily it wasn't cloudy, so I could get a good measurement with the Abney levels. So I sighted from that summit to Alpomish, and I measured 10 to 20 arc minutes up. It was consistent with the previous measurement. So both measurements say Alpomish is taller. So next. Yeah, so 2 different Abney levels looking up. It's good that the measurements are consistent. Next. So to summarize my results, so the resolution is 10. It was like 10 to 15, or 10 to 20 arc minutes difference. So I say 15 plus or minus 5 is the resolution of the device. So 6 kilometer difference, I measure the angle, I can use trigonometry, and that is 25 meters Alpomish taller than peak 4643. And Earth curvature correction just shifts that by like a couple meters. So still about that. And then with the plus or minus 5 arc minutes, that makes, at that distance, it's like plus or minus 8 meters. So my measurements, I had like 4 different measurements from the peaks and then 2 from the tarn. So 6 measurements were all having Alpomish taller. So the more measurements that are in agreement, the higher the confidence. So I was confident enough to say Alpomish is taller. But it still was kind of not very, I wasn't very happy that the GPS didn't work. So 2 years later, I just went back with a better tripod. So the problem with this tripod is you can't balance it. If these legs, you could like bend them, they could like deform and hug the top. So I got a tripod with bendy legs. Okay, next. So I went up in 2025. So that tripod, if you zoom in, the legs kind of deform. It's like a big gorilla pod. And then there's big cliffs all over the side, so I had to clip it to an anchor while it was logging data. So I got the elevation there. 4651 is like the EGM 2008 measurement. It's definitely taller than whatever was on the Soviet map. Geoids are a little different. It's hard to compare directly, but the Abney level measured Alpomish is taller, and then this measurement measured the absolute height. So I want to talk about one more mountain. Sometimes mountains can change over time. So what was a country high point in the past might not be today. So that can happen in Saudi Arabia with a bulldozer, but it can also happen with global warming, with ice cap peaks. So this is what happened in Colombia. So in Colombia, the highest mountains, there's these 2, Colón and Bolivar. They're up on the north coast in the Santa Marta range. There's 5,000 meter plus peaks right next to the ocean. Like you can see them from the ocean. They're really neat. But they've been closed to foreigners for like the past 40 years. Except a couple of years ago, a friend of mine got permission from one of the local tribes to go up there. The issue in the area is tribes weren't giving permission, and the narco drug cartels in the area weren't letting people in. But this guy got permission, and he sent me a picture from the top of Colón. So these peaks were last surveyed in 1939. And Colón was 5775. Bolivar was 2 meters shorter. And so all sources online say Colón is the high point of Colombia. But I didn't want to climb the wrong mountain. I just surveyed Rainier out here, has lost like 7 meters in the past 20 years. So these peaks in like 80 years, they're ice capped, but they're near the equator. They could be melting down even more. So I wanted to know which one was taller. So my friend sent me a picture from Colón looking to Bolivar. And I used my GeoPix analysis on that. So next. This is what his picture looked like. His camera is pretty close to the height of Colón. Bolivar is in the background. And I could identify like 10 different peaks in the background. And those are lower elevation, had been surveyed. And they're not ice capped, so they shouldn't change over time. So I ran that photo analysis on that. I got Bolivar is 7 meters taller, plus or minus 0.5. So I use this software a lot in Washington, so I think it's really trustworthy. So I knew that we shouldn't just climb Colón. We should probably climb both and survey both. But I didn't want to just have one measurement plan, because like in Uzbekistan, GPS can fail. So I'll bring 2 GPSs. And Abney levels can fail. So I'll bring 2 Abney levels and take 6 different ways to figure out which one's taller. So next. So these are the different measurements I took. So the first plan at base camp, it's like a week, maybe 5 or 6 days hiking through the jungle to get up there. It's pretty fun. I have 2 fancy GPSs. I get absolute elevation at base camp Abney level, 2 Abney levels up to each summit. And I can use trigonometry. I know the approximate horizontal distance from digital elevation models. Horizontal is generally better than vertical. So that tells me which one's taller. There's an approach pass. I can take other angular measurements. And then I wanted to bring the GPS up each summit. Then I also want to do Abney level from each summit to the other. And so not all those worked out. We did manage to get up Bolivar. That was like a tricky mixed climb. Hadn't really been done in like 40 years, so it melted out a lot. So we kind of did a new route. Just kind of had to figure it out. So I got 45 minutes of data up there. And then I did Abney level down to Cologne. We kind of ran out of time to do Cologne. But we had I had like 5 different measurements, which one was taller. So they're actually all consistent. Bolivar, 7 meters taller than Cologne. So next slide. This is kind of a schematic of what I did. Bolivar on the right, Cologne on the left. I know the distance, I measure the angle down, trigonometry, get the relative height. And on the bottom is a picture, the 2 fancy GPSs at base camp, measure angles up to each peak. I know distances, angles, trigonometry gets me the heights. So all 5 measurements was Bolivar 7 meter taller. The photo analysis just was the same as all the ground measurements. So what happened was Cologne melted down a lot. And Bolivar also melted down a lot. But Cologne melted down more. And so this high point switched from Cologne to Bolivar. So I can show that in a graph. This is a plot of elevation versus year. The colors are the peak. So blue is Cologne and red is Bolivar. And on the far left is 1939 measurement. Cologne was 2 meters taller. And there's this measurement in 1989 that had Bolivar spike up, but that was just the guy brought his altimeter up, a barometer. I don't really trust that. There's no way Cologne stayed exactly the same height and Bolivar jumped up. So I would say disregard that one in 1990. A couple of my friends brought handheld GPSs up Cologne in like 2015, 2020. And those should be like within 10 meters or so. It's showing it dropping a lot. And then my measurement had them way down, like 57.20 and 57.13. So Cologne melted down 62 meters. Bolivar, if you trust the 1939 measurement, which you can see the summit from the ocean. If you put my theodolite at the ocean and measured it up, 20 arcsecond resolution, and you know the horizontal distance, that should be like within 10 meters. So I would expect 1939 should be pretty good, but that means they melted down over 50 meters. And Cologne melted down more than Bolivar. And I have some theories about why like Cologne's more rounded and Bolivar's sharper. And for some reason, it seems like sharp ice cap peaks melt differently than rounded ice cap peaks. I'm not really sure why. I gotta look into that more. But in this case, the high point switched from one mountain to the other because of global warming. And so now Columbia has a new highest point. So these are the main 4 country high points I surveyed, discovered new ones. I did 3 or 4 more that are kind of similar to those. These are the main ones I want to talk about today. So which ones are still left to still be surveyed? So next. So this is the uncertain country high point locations as of today. So I crossed off the ones on the map that I've done, that I figured out which is the high point. So it's like 8. I did a bunch in West Africa. So some remaining ones, Jamaica, surprisingly, I'm going to go down there next month and try to figure that out. There's 2 candidates there. Guyana, it's this big tepui that's pretty flat on the top, and it's a straight line border of Venezuela and Guyana. So you have to know exactly where that border is to see where's the summit. Let's see, Myanmar, that's probably the most difficult one. There's 2 20,000 foot peaks there. They're both ice cap peaks. They've both only been climbed once. And one of them is maybe harder than Pobeda. I don't know. The guy who climbed it had done winter 8,000ers, and he said that was harder, the Cabo Razi. And that one's a 2-week jungle approach, but there's like been a coup there, so politically you can't go in. So that one's going to be the hardest coming up. There's some left in the Pacific where they just haven't been surveyed. So Tuvalu, they've done LiDAR surveys to narrow it down to 2 atolls. Marshall Islands has like 150 little islands that have never been surveyed. So you either got to go to all of those or, I don't know, wait for someone to fly LiDAR around it. So still a lot of unfinished work. Next slide. So for my overall project, I still got about 40 countries left that I need to climb the highest point. And of those, there's about 10 where the high point is still unknown. So what I do now is every country I go to, I just bring the fancy GPS and just get a good elevation. So I want to get elevation of all the ones remaining and then nail down of all the ones remaining, what's the right mountain. So then the next person coming doesn't have to do like 150 in Marshall Islands. They just do the one. Okay, that's all. Thanks.
So now we can do question and answers. I'll read off stuff from here when I'm doing something from the webinar, but let's start here in the live audience first.
Did your estimates or surveys of the 100 highest in Washington change the boulder list at all?
So it changed. Oh, should I repeat the question? Or?
Sure.
Okay, so did my surveys in Washington change the boulder list? It changed the 100 highest. I added like 8 and subtracted 8 from the technically the 100 highest peaks with 400 feet of prominence. But the boulder list, they just leave it historically the same, never changed. So someone who finished the boulders, I don't want to tell them they didn't finish. That wouldn't be very nice. So I'm just making like a separate, like true 100 highest list. People can, if they want to be super hardcore, they do the boulders and plus the extra 8. Yes?
I'm just curious about the Solomon Islands versus that been there before. Was there anything particular special about figuring out what's going on there?
Oh yeah, for Solomon Islands, so the issue there is it's really dense jungle and it's a really long ridge. And there's a bunch of bumps on the ridge. And it's not been surveyed which is the tallest. Satellite measurements, sometimes they hit the top of a tree and think that's ground. And sometimes they hit the ground and think that's ground. And so you could be like 20 meters off just from dense brush versus ground. And my friend that's been there, he says he got to one bump and then the other one looked higher. And he got to the next bump and the other one looked higher. And like, he didn't have a way to measure it. So based on his report and just satellite measurements, I think it's unknown.
And which island is it? Malaysia or
My geography is not good for Solomon. I haven't been there before. The biggest one, what's that called?
Malaysia, I think.
Guadalcanal.
Sorry?
Isn't it Guadalcanal?
I think Malaysia might be larger.
Yeah, I haven't researched that one enough. I need to look into it.
Can I take one from here?
Sure.
I'm going to read it out a little bit here. So you mentioned that Sherpa Peak in the Washington Enchantments has an easy and a hard sub-peak. Used an Abney level to find out if the harder one was higher, but you didn't say which one it was. Which is the higher sub-peak?
So I guess for Sherpa, they're both, neither of them are easy. It was like, I don't know, 3 or 4 pitches of rock climbing to get to the easier summit, and then the balanced rock is the harder one. So the balanced rock, it's like a boulder that's like overhanging on all sides. And it's kind of like precariously balanced on the cliff. And people do a shoulder stand to get up it. And everyone who climbs that says it's got to be taller. Like, I wouldn't have done all that effort if it wasn't taller. And everyone who skips it says it's definitely shorter. So that's why I wanted to measure. So I measured, it was like 1 to 2 feet shorter. The balanced rock is shorter. So everyone's happy because, well, most people are happy who haven't done either because they don't want to do the balanced rock. Yes?
Are there, or could there be other reasons that the highest might change in a country besides the snow accumulation or mountain ice?
Can you repeat the question?
Could there be other reasons why the high point would change?
Geologic reasons that things could change?
Earthquake.
I have found peaks that are double summits that are very close in height, like within inches. Like in Idaho, He Devil and She Devil, one's like 2 inches taller than the other. So I could imagine at that scale, earthquake or something could affect it. That's pretty rare for a double summit to be that close. Oh, in Colorado, I found a new 14er, East Crestone, 3 inches taller than Crestone, Maine. So at that height, maybe some sort of shift could affect things.
When it gets to that like, minute difference, how do you get confident enough? I mean, just using these same methods, is there? it seems difficult if you're looking at 3 inches.
Right. So the longer you measure, the higher your confidence can be. The sigmas will get lower. There's a standard in the US called the Blue Booking Standard, where if you want to add like a new monument to the NGS database, you need 2 measurements on different days, each more than 2 hours. So in Colorado, I'm going to try to go back in a couple weeks and measure it again for 2 hours again with a completely different setup. And then that'll increase confidence. And then I know some guys who are going with like surveyor level, which is a totally separate way to measure relative height. And if all those agree, that increases confidence. I did measure one in Colorado with the Abney level and got him within a foot on that, like backsighting. So the more different measurements that all agree, the better. There's always some uncertainty though. Yes?
I feel like related to that, I know that the ocean height for 0 is not consistent. And like, I think there's an agreed upon international standard, but is that something you ever have to think about, or do you just like trust the standards and how the devices work? Or, yeah, when you're talking about like differences in inches, I feel like that might come into mind.
Yeah, so defining your 0, that's a really detailed question around the world. So the US has its own like definition of 0, and that's what I'll use in the US. So the government uses something called, it's like NAVD88 is the standard. You report your elevation in NAVD88, that like defines what's 0 in the US. But if you go to Brazil, they have another way to define 0. And it's pretty accurate there, but not accurate other places. And there are some models that define like your 0 over the whole Earth. So those are like global geoids. So what I'll do when I report a number, if there's a local like 0 definition, I'll use that. And if there's not a local definition, I'll just use the global one. So I can use Uzbekistan, I reported local and global. In the US, I'll just report the local one.
Is that a setting on the GPS, or is that something you have to do in your calculation?
You can do that in processing afterwards. So the GPS measures its like XYZ, like measures where it is relative to the center of the Earth.
Yeah.
And then you figure out how high you are above sea level afterwards. Yep.
Can I ask something from here?
Yep.
Amazing work. Who funded all of these expeditions?
Seattle University. I don't have any other job, so and I don't have any sponsors, so I got to be really frugal. And like K2, I only paid for the permit for that mountain. Didn't pay for guides. Didn't pay for. It was just like $2,000 for the permit. Whereas the person next to me was paying $100,000. They had like 10 guides, 10 Sherpas. We both got to the mountain, and I probably had a lower chance of success. But there are cheapskate ways to do it. So sometimes it backfires though. I tried to be a cheapskate on Everest, just pay for the permit and logistics and nothing else. And then I failed. I got to like South Summit and didn't work out. You need to have like 15 stars align if you're doing it cheapskate way versus 2 stars align the expensive way. So sometimes it works out though, being a cheapskate. Yes.
So I'm Sub-Saharan African, and I was just surprised that you picked some of the most notoriously difficult countries to navigate. And I didn't notice Kilimanjaro on your list, and so I'm curious to know why you skipped. It looks like you skipped it. I don't know, maybe I missed that. If you did, I think you should go. I've done it, and I think you would really enjoy it. And as a side question, I'm just curious what drew you to this hobby. It seems like an incredibly challenging way to see the world.
For the hobby, for what drew me to the hobby, I would say it's a really good excuse to visit every country. And there's a tangible objective. Like if someone, like a lot of my friends have different definitions. One, like visit the country. One has to visit a historic site, see a waterfall, and I don't know, one other thing, go to a bar or something. My objective, and then he measures success. And then mine is climb the highest mountain. But then I usually build in enough buffer time in case of delays that I get to see the country too. So I kind of got started in the US visiting every state and then climbing every state high point. So it kind of went from there. So for Kilimanjaro, I did it like 13 years ago in 2013. I wasn't into surveying back then, so I didn't like measure it. There's not really any controversy I'm aware of. I think the sign is on the summit on that one.
Yeah, it does stay with the sun.
Yeah, that was really fun. The logistics, I think I did the 5-day, the Marengu route. Yep. Yes?
I was wondering published like your findings and papers? Like, is it every time, or is it if you just discover something new?
Yeah, so questions about publishing results. So this is one thing I've had trouble figuring out what's the right thing to do. In order to publish a result, it needs to be like broadly important to a lot of people. So like if I just survey Mount Si, I can't publish that in a scientific journal. Like not many people care about it. But there are ways to get the results in a journal. And so one way is if the peak is really significant, or if a significant like phenomenon going on, or if it's a lot of peaks. So for instance, I surveyed the 5 ice cap peaks in Washington and showed how they were changing over time in the past like 60 years. And so that got my surveys of all those like of Rainier in a journal. And then I wanted to get my results of other mountains like Colorado, the 14er. I can't publish that in a journal by itself, that there's a new 14er. But what I did was I looked at what is the accuracy of LiDAR measurements on mountain summits in the US. And so I had like 180 different mountains I put in there. And that's of interest in general because a lot of people want to know how accurate is LiDAR. But the only way you can get the accuracy is compared to ground truth. And mountains are a very like easily identifiable, repeatable location. So I kind of like snuck in the Colorado results in there. And then I published a table of all my measurements. So that got like 180 measurements, me and another guy did. And I did publish one paper on 5 new country high points that I found. So one journal accepted that it was significant enough to discover 5 new country high points, that they just said that collection of 5 that they'll publish. And then hopefully I'm working on one about digital elevation model accuracy, so I can maybe sneak in some other surveys in that one.
Let me do a few from here.
Yep.
With climate change, how static will be your measurements?
The ice cap peaks around the world will be changing a lot. That's one avenue I want to research a lot now. One thing is no one knows how many ice cap peaks are in the world. No one knows how many exist. We know there used to be 5 in the lower 48 states. Now there's only 2. How many are in the world and how are they changing? They haven't really been measured. Like Kebnekaise in Sweden has melted down like 20 meters. Mount Blanc has melted down like 5 meters. But other than those 2 and the ones I surveyed, no one really knows. So I'm working on figuring out, we think there's around 2,000 in Alaska ice cap peaks, but there might be a lot other places. So those are all going to be changing most likely. But non-ice cap peaks, Mount St. Helens, that loses a couple inches of elevation every year I found from erosion. So if you've ever hiked Mount St. Helens, you get on the top, there's a steep cliff on the north side. And if you sit there hanging out, you'll hear all these rocks falling down the whole time. Like I've spent a couple hours up there, you just rocks falling down the whole time. So I started measuring it. I've measured it like 3 subsequent years, always in late September, just before it snows, try to be repeatable. It gets a couple inches shorter every year. And I looked at past LiDAR measurements and past theodolite measurements, and I drew a trend line from the late 1980s, like just after it erupted. I've got like 10 data points, and the R-squared value is like 0.99, super linear. Loses like, I can't remember, like 2 or 3 inches every year. So that's not very common in Washington. It has to be like a volcano probably to be that loose. That might happen in other mountains though.
Let me take another one here. I know from your post that you're super active pursuing high points. How do you train for all these efforts? And for high altitude endeavors, do you ever use a hypoxia tent to accelerate acclimation?
So my training plan is kind of non-standard, but I think it's good for high peaks. So what I do is I do big trips on the weekend and then basically nothing during the week. So this is good for like 8,000 meter peaks. Summit push is always like a 24-hour push. Always a mega day, breaking trail, not sleeping. But Washington, there are a lot of peaks that give you good practice for that. So I'll try to do a push like that on a weekend and then just rest during the week, kind of recover from sleep deprivation, recover from exertion, and do again on the weekend. So I think it was Steve House said like the number of hours per week is the most important, not necessarily how they're distributed. Some people like spread them out, and I think it's fun just to concentrate them. And for altitude, I don't really do anything specific. For some reason, I guess I'm lucky I don't really get affected by altitude too much. I mean, I guess a lot of people can go up Rainier and not feel it in the day. I can go up to like 16 or 17,000 and be okay, like a single push, like fair weather. It didn't work out on, so like K2 I was okay, just acclimated slowly on broad. Everest, I got altitude issues at 8,500. I think it's because I spent like 2 all-nighters back-to-back in the 8,000 meters at the call in the death zone. And that kind of like dropped all my acclimation back down. So I don't really do anything specific. I've heard that the more times you go to altitude, the easier it will be for you in the future. I don't know how accurate that is, but that might help.
Go back to the room here.
If you could go back and stand on top of a peak without having to do the climb, which one would you go back to?
Without having to do the climb? So my favorite peak in the world is Mount Nirvana. It's the tallest mountain in Northwest Territories. So I've done 3 expeditions in there. The climb is part of the fun. The climb and the approach are part of the fun. So it's like 30 miles from the nearest road. It takes like a week to bushwhack and pack raft in. Then the easiest route up is like a 20-something pitch rock climb. So I've done 1 successful time, I've failed once, and then I did another successful. And it's kind of like Yosemite in there, but no one's ever climbed anything. It's just total wilderness. Good granite, everything's unclimbed. If you've heard of Circuit of the Unclimbables, it's like 30 miles south of that. But no one's ever been there. And probably because the access is really challenging.
What did you say that was called?
Mount Nirvana.
I was going to ask the same thing. How do you, since you have a smaller and smaller number of high points left to do, how do you choose what's next? And then also, I know you had some political difficulties recently in Ethiopia and Djibouti actually reaching the high points. How many would you say are kind of on hold right now that you wouldn't attempt due to the difficulty of just accessing them?
So how do I choose which one to do? I think of it a lot of times as doors open and close on different countries. They'll be open briefly and then close. Like Venezuela, the door just opened last month for Americans. So I'm going to go through that door now. The doors might close pretty soon. There are a lot of countries like that where the door's definitely closed. Like Myanmar, the door's closed now for political reasons. Bhutan, highest unclimbed mountain in the world. The mountain's closed for like religious reasons. But it could open. It was open in the 80s. So there's maybe like 10 that are, like North Korea's closed now. But it could open. They were slated last December to open up the ski area at the high point for tourists. So that door was open in 2013. I was like this close to going, but I decided it was too expensive for a grad student. So then the door closed. So there's maybe like 10 where the doors close. A lot of them have like military bases on top. But sometimes those open. Like Sri Lanka military base, when I went in like 5 years ago, they said no permission. But then this year, they're opening it to tourists. But they might close again. So there's probably like 10 like that, where closed now, could open, but unknown. So that's one way I choose where to go. And then the other is the season. Like if I have the summer off, I try to go with the dry season. Like Peru is pretty good in July, so maybe I'll try that one. Like Antarctica, I definitely have to do that like December, January. It is kind of like asymptotically approaching the end. Like I can't do probably can't do 10 every year. They'll just be harder and harder. I do try to leave some easy ones for the end. Like, which one? I guess I'm going to Jamaica soon. That's for surveying. There are some Africa ones. I guess come think of it, maybe I've run out of the easy ones. Seems like ones that used to be easy aren't so easy anymore. Ones that could have been easy in the past, like Burkina Faso, basically drive up, but now they don't issue visas to Americans starting January 1st this year. So I had to cancel that trip. But it could be easy in the future.
Take one from here again. Why can accurate height surveys not be conducted today with AI using, I guess, space or airplane surveys?
I'm sure people are looking into using AI. The problem is you need ground truth. So this is one reason I'm working on this paper comparing ground truth I have for about 700 points around the world that me and a couple other surveyors have measured with fancy GPS, the mountain elevation to digital elevation model. If we can compare to ground truth, then we can get an idea where is the digital elevation model inaccurate, where is it accurate. Maybe then AI could go in and start fixing it in all the rest of the world. But I think if you don't have any good ground truth to work from, it's probably hard to know what to do for AI.
So just in Washington, finding out like which roads are plowed in our own state is already a nightmare. And I'm trying to like wrap my head around keeping track of all of countries, which doors are open and closed, keeping track of like road statuses at all these places and data and like seasonal conditions in territories you've never been to. How do you keep this absolute encyclopedia of research and data under control? And like, do you have any tips and tricks?
This is one reason I started trying to compile all the information I learn. So I try to write as detailed trip reports as possible and then put it on a website and then anyone can read it. And sometimes people that get beta from me, then they'll give beta to me. So like if I want to go to Afghanistan or something, then it's possible I've developed a contact from exchanging beta who's been there, and then I'll ask them about it. A lot of these countries, the situation on the ground changes really quickly, like year to year, month to month. So I don't really know all the beta up to date now on all the countries remaining. It's more like I'll focus on like a subset of 10 this year. And I'll try to find a contact in the country. And then they'll give me the beta on the ground. So that's one thing that's critical, is getting a contact in the country. So like Afghanistan, I would never went there unless I knew a guy on the ground in the village at the base of the mountain who said it was safe. Because like the US State Department says it's level 4, don't go there. But he says this part of Afghanistan is safe, the walk-on corridor, because the Taliban aren't there. So contacts are super important. Beta, I think if you know contacts, then you can get the beta from them. But developing contacts is hard. So that just takes a lot of time. And meeting up with people for trips, and then they'll introduce you to friends, kind of gets better over time.
Can I do another one from here real quick? Sorry. Great talk. Your stories are fascinating. Have you ever considered leading other researchers, like geologists, up some of the less traveled peaks to better understand the formation of these peaks and ranges?
That would be fun. I mean, I led a lot of, if any of you guys done the MIT Outing Club Winter School, anyone done that? Yeah, I led a bunch of trips for them. So that's pretty fun. We tried to get one started in Seattle a couple years ago. Before COVID, we were doing trips. So it's definitely fun leading other people up trips. I don't know how to connect with other scientists that need led up. I mean, when I survey Rainier and the ice cap peaks, I get a bunch of people helping with that. So it's kind of like scientific. Yeah.
Do you have any mountains that are approximately around the Rainier difficulty or so that you would recommend just as wonderful climbing experiences?
Like Rainier difficulty that are like other countries, or?
Yeah, just around the world that you thought were just wonderful mountains to climb.
Let's see. I don't know, Uzbekistan is one of my favorite areas because the granite's really good. You can do just like a couple pitches of rock climbing and get to a summit. Mongolia is pretty neat. Super remote, but the mountains are kind of like Rainier. It's like the Emmons route on Rainier to get the high point in Mongolia. It's like a standard glacier hike, but you have to drive like across this like steppe where there's no roads for like 2 days just to get there. And then it's at the tri-border point between like Russia, Mongolia, and Kazakhstan, I think. So super remote. That's pretty cool. I guess my favorite mountains are in Canada. So if you go, I kind of like the super remote ones. If you can make your way up to Nunavut, Ellesmere Island, there's a lot of amazing mountains. They're kind of like Rainier there, but most of them have never been climbed. And it's just no civilization anywhere around. Huge ice cap and then just little peaks sticking up. They're all pretty much non-technical. You can snowshoe up them all. Getting there is kind of challenging.
Eric, I've got one. So Iceland's not on, I'm sorry, South Pole is not on your list, is it?
I put Antarctica on my list. It's not like a UN member or an observer, but it'd be really weird to just have it not there. Just ignore it. Mm-hmm. So I stick that as country. So I want to do Vinson, high point of Antarctica.
You do, okay.
I mean, South Pole would be neat too.
I meant Antarctica, right, okay.
Yeah, Vinson is really expensive. I'm trying to figure out clever ways to get there, like a boat or something, but. So that one, that might take a little bit of planning to do a cheapskate way.
What's your travel rewards credit card?
I have something with most airlines. Yeah, this worked out well recently because you can get, if you wait till like the day before for an international flight and you get with miles, they'll like cut the miles in half. So I had to fly back from, I was in Yemen just before the Iran issue came up. I had to like change plans last minute, fly out of Cairo, but like day before, they dropped the miles in half, so it's like super cheap if you have the miles. But if you buy it with dollars, then it's not as good. So I try to get a credit card with every airline. Some of my friends have the deals where you get the free, like the VIP lounge in every airport, and they get 3 or like 2 guest passes. And so it's unlimited buffets in there. So if we're an airline in a different airport every 3 days, then and they don't check if you just kind of sneak some in your backpack. So basically all our food is free on the trip.
Any more here? I figure we can do one more. I've got a couple here I could ask. This might be quick. When are you climbing Olympus Mons?
Once there's a good transportation to Mars, I'll be on it.
So I'll send this one to you later. It's a suggestion about how to maybe get other scientists involved. I mean, I think didn't you answer what your favorite high point to date has been?
My favorite in the world is Nirvana in Northwest Territories.
Right,
I'd say my favorite country high point is Uzbekistan.
Okay.
I mean, there's not many I've done twice, but that one I've done twice.
They also asked, does actually carrying all your equipment, how much does that affect your chance of summiting, do you think? At all?
It definitely decreases chance of success. So this was pretty pronounced in Colombia, because Pico Bolivar, I wanted to haul both fancy GPSs up there just in case. But I didn't want anyone else carrying it because I didn't want them to like slip on it and break it. And so then when we got up closer, I realized it's really like a technical mixed climb. And the guide we were with didn't really want to lead it, so I had to lead it. So that would have definitely decreased chance of success if I brought all that equipment. So I ended up just bringing one to the summit, try to go ultralight.
I was curious, like when you say you have to walk in like 6 weeks just to get there, is it hard to be able to carry enough food and water to get to the actual base of the mountain?
Usually if it's far in, like I think K2 is like 50 miles in, but then hire mules and porters to bring stuff in. I'm not carrying 6 weeks of food on my own. Except in Greenland, I carried like 2 months, 60 days of food, but it was on sleds. So I did a traverse in Greenland. This was like to prepare for the Greenland high point. So it was like 400 pounds of food, 4 sleds, like a 2x2 grid, and we had kites, and we kited across, just towing all the gear. So if it's a flat ice sheet, the extra weight doesn't really make any difference. Except getting it up to the ice cap was really hard. It took like doing like 5 miles a day or something. But if it's over land, I'll like pay for porters and donkeys. In the 6 week kind of trip, like K2, most of that is a lot of killing time in camp of that 6 weeks. Maybe it's like a week to hike in. And then you'll do acclimation. But like between Broad Peak and K2, I took like 11 days waiting for the weather to clear. Just reading books. We say it's acclimating, but it's just kind of killing time.
And how much wrap tack did you bring on Uzbekistan? You just have like a separate bag full of like cord?
You here brought like 40 meters of cord. I should have brought more because there's nothing there. It was, so what I usually do, if I had more, I would have left it, but I would just sling a horn or have 2 nuts, and then I back it up with a cam, and then weight it, and then I trust it, and then go down on 1 strand. But yeah. Oh, in Northwest Territories, we did this 30 pitch route up this face. It's kind of like El Cap. So we got 3 full trad racks on there. And we left like 2 of them on the mountain. There's nothing there. And sometimes you have to leave a 2 cam anchor because there's no horns. So a lot of gear left on that one.
All right, Dr. Gilbertson, thank you so much for. And hopefully you'll be able to find something at the MIT Coop with the gift certificate we got for you as a speaker gift.
Oh, thanks.
So, MIT sweatshirt, who knows? And then wanted to just thank everyone here for showing up. This is pretty good attendance. Really appreciate you guys coming, as well as everyone on Zoom. We had a lot of people sign up for this one, so you've got a lot of people really interested in your talk. So, hope everyone had a great evening. Look forward to seeing you guys at another, MIT or Ivy Plus event sometime. Have a good evening. Thank you. Appreciate it.